Hello, everyone. In this lesson, we'll discuss blockchain and cryptocurrencies within the context of fintechs. I'll begin with a discussion of the key features of blockchain. Then explain how blockchain technology works. Next, we'll discuss why blockchain technology is useful and how blockchain technology can be leveraged with smart contracts. And then we will describe the key characteristics of cryptocurrencies. And finally, we'll describe some of the popular cryptocurrencies and explain the practical issues regarding blockchain and cryptocurrencies. So what is blockchain? Blockchain is a decentralized digital ledger that records transactions across many computers in a way that ensures the data is secure, transparent, and can't be changed without the consensus of the network. Let's now discuss the key features of blockchain. And we'll begin with decentralization and transparency. Decentralization eliminates the need for a central authority and reduces the risk of data tampering. And transparency is a feature of blockchain because all transactions recorded on a blockchain are transparent to all participants in the network. Other key features of blockchain are immutability and security. With immutability, once a transaction is recorded on the blockchain, it cannot be altered and it cannot be deleted. So immutability ensures that the data remains accurate and tamper-proof. Now, with security, blockchain uses advanced cryptographic techniques to secure the data. So the data, for example, is encrypted using advanced techniques, and that enhances the security of the data. Let's see how blockchain works by looking at the components and processes. Key components are the blocks and the chains, which together form a blockchain. Now, a blockchain consists of a series of blocks that are linked together chronologically, each containing a list of transactions and forming a continuous chain. Transactions are grouped together into blocks, and each block is linked to the previous one, hence the name blockchain. Now, once a block is full of transactions, it's added to the chain and becomes a permanent part of the record. The chain is distributed across many computers, and that's called the nodes. And as a result, no single person or entity controls it. And as mentioned earlier, cryptography is used to secure the data and verify transactions. A key process for blockchains are the consensus mechanisms. Now, consensus mechanisms are used by blockchain networks to ensure security and integrity of the data, as well as the accuracy and validity of transactions. In the context of blockchains, proof of work and proof of stake are two of the most common consensus mechanisms. Proof of work is a consensus mechanism used to validate transactions and add new blocks to the chain. Again, it is used to validate transactions and add new blocks to the chain. It ensures security and prevents fraud by requiring participants called miners to compete to solve a cryptographic puzzle. Now, the puzzle involves finding a number that, when combined with the block's data and run through a hash function, produces a hash that starts with a certain number of zeros. So now let's break it down into simple terms. Transactions are broadcast to the network. The participants, which we will call miners, collect transactions into a block. They then compete to solve the complex cryptographic puzzle based on the block's data. This puzzle is called a hash problem. The first miner to solve the puzzle ends up broadcasting their solution to the network. Other nodes, which are the computers, if you recall, verify that the solution is correct and that the block is valid. If it's valid, the block is added to the blockchain, and the winning miner gets a reward, usually new coins plus transaction fees. Now, an example of a blockchain that uses proof of work as consensus mechanism is Bitcoin. Now, let's look at the other type of consensus mechanism, and that is proof of stake. Now, proof of stake is a consensus mechanism used in blockchain networks to validate transactions and add new blocks to the blockchain. Again, proof of stake is another type of consensus mechanism, and it's used in blockchain networks to validate transactions and add new blocks to the blockchain. In proof of stake, validators are chosen to create new blocks and confirm transactions based on the amount of cryptocurrency they have staked or locked up as collateral in the network. An example of a blockchain that uses proof of stake is Ethereum. Now, let's compare proof of stake and proof of work. Proof of stake has a couple of benefits over the proof of work. First is energy efficiency. There's no need for massive computational power, which is required by proof of work. There's also a low barrier to entry with proof of stake. Anyone with enough tokens can stake and participate in the proof of stake consensus mechanism process. And the last benefit of proof of stake over proof of work is scalability. Generally, proof of stake is more scalable than proof of work, so that enables faster transactions. Let's now talk about smart contracts. A smart contract is a self-executing program that runs on a blockchain network. It automatically enforces and executes the terms of an agreement once predefined conditions are met. So the contract is automatically enforced and executed without the need for intermediaries such as the lawyers or financial institutions. So let's consider an example. Assume a smart contract for crowdfunding on the Ethereum network. Now, if a project raises 100 Ethers by a deadline, the funds are released to the creator. If it doesn't, the Ethereum is returned to the backers. Now, no one controls this contract manually. The contract enforces itself automatically. Now, based on our understanding of blockchains and building on this foundational understanding, we will now discuss cryptocurrencies. Now, cryptocurrencies are digital or virtual currencies that use cryptography for security. Now, unlike the traditional currencies like the dollar or euro, cryptocurrencies are decentralized and typically run on blockchain technology. So they are running on a distributed ledger enforced by a network of computers. And please remember, this network of computers, each one is called a node. Now, a crypto wallet allows you to store, send, and receive cryptocurrencies like Bitcoin, Ethereum, and other cryptocurrencies. It's kind of like a digital version of a regular wallet, but instead of holding physical cash, it holds the keys you need to access your cryptocurrency. Let's now look at some key characteristics of cryptocurrencies. Now, cryptocurrencies operate on decentralized networks using blockchain technology. And there is anonymity and privacy, such that the identities of participants are often pseudonyms. And cryptographic techniques are used to secure transactions and control creation of new units. Let's now discuss Bitcoin, which is the first and most well-known cryptocurrency. Bitcoin was launched in early 2009 and is the first example of blockchain technology applied as a currency system. Bitcoin uses the blockchain network, so there's no central nexus of control. And the blockchain network allows Bitcoin's participants to transact peer-to-peer. And a copy of the network's transactions are maintained on many different computers. Let's now discuss the usefulness of Bitcoin as a cryptocurrency. First, the decentralization and security of blockchain networks allow people to transact without banks. And that's one of the key usefulness of Bitcoin as a cryptocurrency. Now, Bitcoin and other cryptocurrencies allow people to transact securely and anonymously. And this can make the global financial system more accessible. Let's now turn our attention to the second most popular and prominent cryptocurrency, and that's Ethereum. Now, Ethereum was launched in 2015, and it runs on a decentralized blockchain platform, and it pioneered the idea of smart contracts. The Ethereum blockchain is a decentralized platform that enables developers to build and deploy smart contracts and decentralized applications. Now, on the Ethereum network, Ether is used to power the applications and pay for transactions. So invariably, Ether is the world's second-ranked crypto based on market cap next to Bitcoin. Now, many industries use the Ethereum blockchain platform as it provides a high level of security, transparency, and efficiency. The third cryptocurrency we'll discuss is Litecoin. Now, Litecoin was created by Charlie Lee, a former Google engineer, in 2011. Litecoin was created as a lighter version of Bitcoin, and it's focused on faster transaction times and lower fees. And its purpose was to provide a more accessible and quicker alternative to Bitcoin, especially for small transactions. So let's now look at the funding of cryptocurrency projects. So pretty much the funding of the creation of cryptocurrency coins. Now, the initial coin offering, or ICO, is a fundraising mechanism for cryptocurrencies. An ICO can be launched to fund the creation of any new cryptocurrency coin. And what happens is that participants interested in the new coin project can acquire tokens during the ICO and receive a new cryptocurrency token from the issuer. So it's pretty much like an IPO for stocks. Cryptocurrency tokens may represent a stake in the company or the new cryptocurrency coin project. And cryptocurrency tokens may have utility related to the product or service offered by the new coin issuer. Now, ICOs can raise funding directly from anyone with a crypto wallet and anywhere in the world. ICO funding is direct, therefore it provides liquidity and requires minimal bureaucracy. On the flip side, there is a higher risk of ICO scams and fraud because of limited regulation and enforcement of ICOs. So what are the advantages of cryptocurrencies? Well, cryptocurrencies operate on decentralized networks. We've emphasized this point earlier on. Transaction fees are reduced, processing times are also reduced, and cryptocurrencies are accessible and transparent based on the nature of how it is set up. And on the flip side, that's the disadvantages of cryptocurrencies. There's high price volatility, which leads to fluctuations in the value of cryptocurrencies. There's also uncertainty on how governments will regulate and tax cryptocurrencies. Now, the regulation of cryptocurrencies is still evolving. And cryptocurrencies, as we've come to realize, are not immune to hacking and other security threats. And also, cryptocurrencies are not widely accepted. Let's look at some practical issues associated with blockchain. Now, despite the potential that blockchain applications have, blockchain is not yet mainstream. Now, blockchain applications require user-friendly user interfaces. And of course, blockchain can make back office processes more efficient. Let's now look at some applications of blockchain. In finance and banking, blockchains can streamline and secure financial transactions by improving transparency and traceability and lowering costs. Now, for intellectual property, blockchain applications can provide a decentralized and immutable record of ownership of an IP, and it will make it easier to track and enforce IP rights. In supply chain management, the immutability associated with blockchain networks means that one can have an immutable record of transactions. And this is ideal for tracking goods. And it improves efficiency and reduces fraud. In healthcare, blockchain can be used and it will enhance data security and privacy. And in the voting and governance area, blockchain can also be used to create secure and transparent voting systems, thereby reducing the risk of fraud. So this brings us to the end of the blockchain and cryptocurrency lesson. I look forward to delving into other areas of fintech with you.